Hello friends, today we are going to look at another medium level problem from Leetcode. The problem number is 739. It's about daily temperatures. Given a list of temperatures T, return a list such that for each day in the input tells you how many days you would have to wait until a warmer temperature. If there is no future day for which this is possible, put 0 instead. Okay, so for example, they have given us a list over here. So let's understand the problem in a little more detail. So we have these values. So these are the values from the array example that they have given: 73, 74, 75, 71, 69, 72, 76, and 73. Okay, so how many days 70 this guy has to wait in order to see a warmer day? This is the last day, so there is no other day that we can get from here. Then we have 76. 76 can see a colder day than this, but not a warmer day, so this is also 0. So 72 has to wait just one day, that is 76. 69 has to wait one day. 71 has to wait 2 days, right, to see a warmer day. And similarly, 75 would have to wait 1, 2, 3, 4 days to get a warmer day. And 74 has to wait just one day, and 73 has to wait just one day. So this will be our output for this. So 1, 1, 4, 2, 1, 1, 0, 0. There is an additional note to the problem given. The length of the temperatures will be in the range of 1 to 3000. Each temperature will be an integer, so the temperature will be between 30 to 70 degrees, 30 to 100 degrees. And they say that they can have around 3000, 30,000 elements in this array. So the size of this array could be between 1 to 30,000. This is the constraint given to us. Okay, so as I always recommend, to give it a try yourself before you look at the solution. So there are multiple ways to solve this problem. So you can think, so you can just explore different approaches using different data structure and see which one fits in. So here is the example from Leetcode, the same example that we have just seen. So we have 73, 74, 75, 71, 69, 72, 76, and 73. And we know the results also. We have computed it earlier as well. So let's just put the result over here. So here for this problem, let's try to understand this problem in more details and see how we can come up with different kinds of solution for the same. So basically, if you take a look at this problem, one thing that you'll notice is that the last element is always having an answer of 0, right? This is one fixed thing. We can start from back and go towards the front because we need to find the next warmer day. So we should come in the reverse order so that we understand that when we have seen the last day. So if I go from front to back, we'll never know what days are going to come. But if we are coming the other way around, we'll always know that what days are there. And what we are going to do is we need to know the next warmer day. So what we are going to use is a stack over here. Okay, and we'll see how this stack will unfold this problem and help us in guiding towards the answer. So let's build a stack over here first. Okay, so we have a stack and we will have our algorithm over here, how we are going to use this stack in order to come up with the solution. So what we are going to do is we are going to iterate this array backwards. So when we start iterating, say this is our input array that we have considered over here. So let's take this example. So the index that I'll be starting with is the index 7, right? So for index 7, what we are going to do, as we have just discussed this, for this last index, we know that there is never going to be a a warmer day after this date. So let's also have a result array in place over here, and we'll fill up the result array as and when we get the data from the input array and the stack. So let's create our input array once more over here. Okay, so one thing we are certain is that for the last index, the value is always going to be 0. right? Because there is no warmer day as we have just talked about. So what we are going to do over here, we are going to store the indexes and not the values, okay? Because using the index, I can access the value at any point of time. So what I'm going to do, I'm going to put the index 7, and I will I'll also put the value in the bracket for our reference. But in reality, what we'll be storing is the index and not the value, okay? So we put this value as a base condition and we start our iteration. So we'll be starting from array length -2. So let me rewrite this again. Okay, so what are we going to do? The first step that we are going to do is we are going to put the last elements index into the stack. So we have done that already. Our stack has this value 7 because this is our input array wherein we have 8 elements and 7th is last index, and also we are showing the value denoted by this. And then we are going to iterate the array backwards. Okay, now the first index that I'll be getting is a 6. So what I'm going to do, I am going to peek into my stack, and whenever I see that the value on top of the stack is colder than me, I am going to pop out until the stack is empty, or when I find a value that is warmer than today. So why I am doing so? Because I am trying to, since we are coming from the back, we are trying to find out the warmer day. So the next step in the algorithm would be, so we are going to pop elements out of the array until the array is empty, or we find an index whose value is warmer. So what I'll start doing is I'll start popping out from here. So I'll first check this value that I get an index 7 and which is 73 degrees. So I'm going to remove it because it's colder than this. And then I see my stack is empty. The next step, so let's consider that initially all our results are set to 0, right? So now what we are going to do, we are going to add the current index, that is 6, and for reference we'll be just keeping the value over here which is 76 over here, okay? And we are going to update the result. So when do we update? If we find the index from the stack which has a warmer date, then we are going to update. Otherwise we are not going to update, we are going to keep 0 as is. So for this index we did not find anything, so we are going to keep the result as is. Okay, so we are done with this. So we could not get a warmer day after 26 degree Celsius or Fahrenheit, whatever. Okay, now I decrement, I come to 5, and the 5 I get a result of 72. Okay, so let me put it over here. The temperature is 72. I do a uh, I do a lookup on the stack, and what I get is a value that is I get an index whose value is higher than the current temperature. So I know the my result would be stack top minus I. So what is the stack top? Stack top is 6 and I is nothing but the index, current index, which is 5. So I get a result of 1. So I am going to replace this 0 and put a result 1. And once I do this, what I'm going to do, I am going to put this result back into the stack as well. So I am going to put a 5 and I am going to keep the temperature as a point of reference. Okay. So I'm done with my 5. I go to 4. For 4, we see the temperature is 69. Okay. So what I'm going to do, I am going to look at the stack top and I see, okay, I have a warmer temperature, right? So what I'm going to do, I am going to check the stack top, which is 5. My current index is 4, so I get a value 1. So I change this value and put a value 1 over here. Okay, and what I'm going to do, I'm going to put this result back into the stack. Okay, so we are putting 4 and the temperature corresponds to it is 69. Okay, so we are done with this. So we go to the third index where I get a temperature of 71. Now you see the interesting part. We are over here 71 and we see that stack top is does not have a warmer temperature. So we keep popping until we find a warmer temperature. So we remove this and we get a 5. Okay, 5 is warmer than me. So stack top minus I, stack top is pointing to 5 and I is pointing to 3. So I know a warmer day is just 2 days apart. And look how we are putting the how we are removing this element from the stack, right? And we are putting the current index over here, 371. Now you see this value that we have removed basically is redundant, right? Because if I get a temperature like 70 on the second day, 69 will never contribute to my result. 71 will always do because 69 is 2 days apart. So I am removing the smaller values that holds no relevance to me at this point of time. Okay, so we are going to go move ahead, and this now comes to the index 2, which is 75. So to get 75, I see that on the stack top we have 71. So I do this step, keep popping. So this is removed. Then I get a temperature of 72, which is also lower. I pop it out. Then I find an index whose value is greater than what I need. So I have a stack top at 6 and my current index is 2. So that day is 4 days from now. So I update the result and put a 4 over here. Okay, and I'm going to put the current value into the stack. So I'm going to put 2 over here, and 2 has a value of 75. Now I move to 1, wherein I have a value of 74. So I just look at the stack top and I see, okay, the next value itself is the same. So 2 minus 1, it's just 1 day apart. So what I do is I don't remove it. I put the updated result of 1 over here, and I put this value as well into my stack. Now I come to the last index, which is 0, where I have a value of 73. I look at the stack top and I see, yeah, there is a warmer day on the top. So I do a 1 minus 0 and I get a 1, and I put this result over here 1. Okay. So these values have been deleted. Okay. These all have been deleted. These two has not been changed. So what I'm going to do is I'm going to again put this result back to the stack. This loop will break, right? Because we have reached the end of it, and you can see that your result is ready over here. So this is the solution all about how we are using the stack in order to come up with the solution. So this is a very simple solution. We are just doing a traversal of order of n, just going over the stack, and in the worst case we'll be storing order of n items as well. So both in terms of storage and time, we'll have a complexity of order of n. Again. So let's move over to Leetcode and have a look at the solution. So we are going to need an integer array wherein we'll have the result stored for us, and it will be of the same length as the uh, actual input array. So we are going to construct that, and at the end we are going to return the results. The other thing that we need is a stack wherein we'll have the integers. We'll be storing the index in the stack, and so let's call it stack of new. Okay, and as we have discussed that we are going to, the first thing that we are going to put into the stack is the last element of the very last element that we have. So this is the part of our initialization condition. So we are going to do the same thing, stack dot add, and we are going to put the index, so t dot length minus 1. This is the last index. So we are putting the index again just to give you a reminder, and we are not storing the values over here, right? Okay, and now we'll have our backward iteration. Okay, so this is the loop for the backward iteration, and what we'll be doing, we are going to pop from the stack until the stack is not empty, and the second condition is we are going to peek on the stack. So we are going to see, we are going to peek. So peek will give me the index, right? And I'm putting that index into the array to get the value, because we need to compare the temperature, right? And we are going to compare it with the current temperature. So as long as it has a temperature which is lesser, we are going to do a pop from the stack. So we are continuously popping out of the stack until we find a warmer temperature or the stack becomes empty. This will ensure this condition over here. So pop elements out of the array until the array is empty. So my bad, it will be stack is empty. So let me just change. Okay, until the stack is empty or we find a warmer day. So that's what we are doing. So if not, what are we going to do? We are going to update the result. So if my stack is not empty, what I'm going to do is I'm going to update the results. ith index. So we have updated the result, and once we are done doing everything over here, we are going to add to the stack the current index. Okay, so we are adding that index after we populated our result. So let's run this code. So this is the exact solution, entire solution that we have discussed over here as well. So let's run it and check. Okay, it has been accepted. So one minor change that I forgot is you should make it less than or equal to. So just think of a case that you have 72, 72, 72, 72, 72, 72 like this every day. This is 0, 1, 2, 3, 4, and so on, right? So if I put a 72 4 over here, so if I get the same temperature, I should delete it and change it to 3, right? So if I am making it less than, then it's not going to take care of that. So I have to make it less than or equal to. So if it is less than or equal to, then also I'm going to remove it because I am going to put myself there, right? So previously say 3 was there, so I should remove 3 and put 2. I should remove 2 and then put 1, right? So it should go on like that. So it should be less than or equal to. And let's submit and see for a broader range of test cases. Well, it has been accepted. We have around 17 milliseconds, better than 50% of the submission. But yeah, the whole point is to understand this algorithm, how we are using a stack in order to come up with the next warmer day. There are different type of solution available for this as well. So this is the stack-based thing that we have done and approach, and which is a very simple solution. And do let me know what you think about the solution. I try to keep it as simple as possible so that it is easier to interpret during an interview and to explain it within a very short span of time because we don't have a lot of time during the interview. So do let me know your thoughts on the video. Do give it a like if you think this solution was helpful for you. Do subscribe if you haven't done so. Do share with your friends. And once again, thank you for watching the video and see you guys soon again. Bye bye.